Okay, in this video, we're going to go over lesson 3 in our statistics unit. We're going to start out by checking homework number 2. So please take a moment to take out your homework, check it over. Since I'm not there today, please just make a note, mark any questions you'd like to go over, and we'll go over them together in our next class. And if you want a little bit more detail as you're checking your homework, you can go onto Canvas and check with the full answer key. So once you've had a chance to go over this homework, please take out your notes packet and open up to lesson 3 so that you can follow along with today's lesson. We're not going to do a lot of questions together, but I want to make sure that you are looking along in your notes and trying the questions with me as we go through them in the video. And also make sure you have a calculator. Okay, so what I'd like you to start with is the Do Now Part A. This should feel like a review from lesson 2, so please just pause the video. I'm going to keep going, but I'd like you to pause it for a moment and try it, and then continue back and we'll go over it. So in this question, we're being told that we have a normal distribution of data. The mean is 70 and the standard deviation is 5. And we're being asked to find a few different probabilities. Again, all that means is find the percent under the curve over a different set of intervals, right? So each choice here is giving us a different set of values to look between. And we're going to round to the nearest tenth of a percent for each question. So the first question says, what is the probability, or what is the percent of scores that fall between 60 and 75? So I'm going to go to my curve and I'm going to label 70 at the middle because that's my average. And since my standard deviation is 5, that means if I, let's say, add 5 to 70, at my z-score of a 1, I should have the score 75. And that's as far as I want to go to the right because it's asking me to find the probability between 60 and 75. So think of that as like the upper bound of this interval. And then we're going to go down to 60. So if I subtract a full standard deviation from 70, subtract 5, I would get 65. And then if I subtract another standard deviation away from that, I would get down to 60 at a z-score of -2. So I am looking right now to add up the percents between 60 and 75. Oops, I went a little too far there. 75 being at the 1 standard deviation above, and 60 being at the 2 below. And if you take a moment to add up these percents from a z-score of -2 up to a z-score of 1, you should get a percent of 81.8%. Okay, so using this same understanding, we're trying to find the percent of scores that fall between two values. I'd like you to look at Part B, and just for a moment, I want you to think about why Part B looks a little bit different than Part A. And if you've had a moment to think about it, you're probably thinking, well, first, like, where do I put these numbers, right? Because our normal curve that we're looking at here has z-scores, right, which is the number of standard deviations we are either above or below the average, that are integers up to 3 and down to -3, or halves. So there's no room for anything other than a full or half standard deviation. So if we're thinking like, where is 62? Well, 62.5 would be exactly here, right? That's halfway between 60 and 65. So that would mean like 62, I guess we could like approximate. It would be like right over here, I guess. And then 84, well, let's think. So this would be 80. This would be 85. So 84 might be like a little bit, to the left of 85. And I would still be trying to do the same thing, like basically add this up. But the problem is like, I don't know exactly like how much of this 4.4% do I take? Do I take half of it? Do I take a little more than half? We wouldn't be precise. We'd be approximating if we use the curve to try to answer this question. So instead of using the curve, we're going to use our calculator. So the first thing we're going to do is we're going to go to our calculator and we're going to click 3 buttons. We're going to first click second. Then we're going to click VARs. And then you're going to really click down to the second choice. It says normal CDF. Now I'm going to show you right now like what that looks like in my calculator. Mine on here is a little different than yours. But you know, you'll still be able to see the functionality of it. And then later in your notes, I have a picture of what it looks like more so on your calculator. But the second key is that blue key right above alpha. VARs is right above tangent or next to clear. It says VARs, and in blue it says like distribution. So second VARs is actually bringing you into the distribution menu since we're looking at a normal distribution. And then normal CDF is choice 2. So you're going to want to click onto choice 2. Now, your calculator might look like this if it has an older statistics software on it. And in that case, just know that I can update it for you next week. But otherwise, I'm just going to go back to the notes for a moment. Your calculator at this point is probably showing you a screen that looks like this. When you clicked on normal CDF, you probably have this menu that says lower, upper. The symbol there is for average. The symbol under that is for standard deviation. And then it should say paste. So we're going to type in 4 numbers. Lower and upper refer to the lower bound and the upper bound of the interval that we're currently calculating. So if I go back here, I'm actually just going to draw myself like a simpler version of this curve. So I know 70 is in the middle. That's my average. 60 would be like somewhere to the left. Sorry, 62. And 84 would be, you know, somewhere to the right. So if I'm thinking, okay, I want to try to figure out what this is, right? The probability or the percent of values that fall between these two scores. 62 is my lower bound here, the left side of this interval. 84 would be my upper bound. 70 is my average. And then we were told earlier that 5 is the standard deviation. So on your calculator, again, you were given lower, upper, standard deviation. Oh, sorry, average, standard deviation, and then the paste key. You're going to type in this order, 62, 84, 70, 5, and then you're going to hit enter at the end on paste. And what should happen, I'm just going to go back to my calculator now. What should happen is that it should look like what mine will in a moment. So I'm going to type in my lower bound, my 62. If yours happens to look like this, you're going to type in exactly what I'm typing in, and you just have to put a comma between each number. So 62, comma, 84, comma, 70 for the average, comma, 5 for the standard deviation. And then when you click enter from that other menu on paste, it should paste this onto your home screen, and then you have to hit enter to calculate it. So you basically have to hit enter twice, once on paste and then once on the home screen. And then they asked us to round everything to the nearest 1/10 of a percent. So I'm just going to multiply this by 100 and we get 94.3%. So now I know that the percent of scores that fall between a 62 and an 84 on the same set of on the same distribution of values that we looked at in part A, I can calculate this without actually having the curve in front of me. Okay, now I'd like you to try part C, and I'd like you to start out by drawing a picture. So like pause the video, you don't even have to do the whole part of it. Just get yourself a visual, and you're gonna probably feel like you're missing something because we do have to go through the same menu in the calculator. But again, pause, see what you think. Excuse me. Okay, so I'm going to draw a picture. We have 70 in the middle. Now we're looking for the probability or the percent of values that would be greater than 71. So 71 is probably like right here. Greater than, so we're going to the right of it. And when I look back at what I'm going to type into my calculator, like 71 looks like it's the lower, right? It's the lower end of this interval. But you might be asking yourself, like, well, what's the upper question mark, right? Because we don't really have one. We want the calculator to calculate the percentages, add them up from 71 all the way to the right, like continue to go. So what we're actually going to do is just tell our calculator, here's a really big number, and that is telling you to keep adding everything up to the right of 71. So we're going to use just like 9,999. Like give your calculator a bunch of nines. That's going to be our upper. So 71 is our lower. 9999 is our upper. Same average, same standard deviation. You should hit paste. Enter twice. If you want to multiply it by 100, again, I'll do this one again with you in the calculator just so you go through the keys. Second, vars, choice 2. So for this one, we're looking at everything greater than 71. So 71 was the lower. 9999 is the upper. Same average, same standard deviation. Times it by 100. 42.1% would be all the scores that fall above or greater than 71. And then for the last one here, probability of a value less than 62. So here's my middle, 70, 62 would be somewhere over here. Less than, like that. And now if you're thinking, okay, what do I do with my interval? Well, in this case, 62 is the upper side, right? The right side of this interval that I'm trying to calculate. So what is the lower? So in this case, I need to kind of make up a really small number. So to make things easy, I usually just do the same number, but with a negative in front. Negative 9,999. Just something really, really small. Again, always in comparison to the numbers that you have. So if I paste this from before, just to kind of make that easier for myself, in your calculator, when you click second vars, choice 2 for normal CDF, you're going to type in negative 9,999 into your lower, 62 in as the upper, same average of 70, same standard deviation of 5. And for this value, when you multiply it by 100, you should get 5.5%. And I'll go through that in the calculator now just to show you. Second, vars, choice 2. The lower bound here we made up as negative 9,999. Again, you don't have to use that exact number. Just use something much smaller than 62. So 62 is the upper, 70 is the average, 5 is the standard deviation. Hit enter, times it by 100. There's our 5.5% to the nearest tenth of a percent. Okay, so that really is everything in terms of how to use the calculator to add up percentages underneath the normal curve when you don't have the actual curve in front of you to look at. If you look a little bit further down in your notes on the next page, there's just like a nice visual of what you should have been seeing in your calculator. So the first picture there is what you should see when you click second vars. Like, so press second and then vars, that's the distribution menu. And then when you click into normal CDF, actually, let's do that in a different color. When you click normal CDF, that should bring you here. And then you should be able to type in those 4 values, click enter on paste, and then click enter again to actually calculate it on your home screen. And then just a reminder here about using the lower bound and the upper bound when you don't have one, to use something really small, potentially using negative 9,999 or positive 9,999 as that boundary to make sure that your calculator has a lower or upper bound when it doesn't give one to you in the problem. Okay, I'm going to give you a moment. I'd really like you to pause the video, and I would like you to try this next question. There are 4 parts to it. pause, give them a try. We'll go over this one together in the video, and then we'll be done with this lesson. Okay, so take a minute, please pause, please try, and then continue on with me. So for number one, or for this next question, we're talking about the lifespan of a particular brand of car tire. So, the average lifespan of this tire has an average of 51,200 miles. So I'm just going to kind of note that using my symbol for average. And it has a standard deviation of 8,200 miles. All right, so each part of the question is going to refer to that same mean and that same standard deviation. We're told that the lifespan of these batteries is approximately normally distributed, so we can use second VARs, normal CDF, to calculate these probabilities. And for this question, we're being asked explicitly to express our answers as decimals to the nearest thousandth, so we're just going to round to 3 decimal places. So for each of these, I am going to draw a picture because I do think that is a very helpful step. It gives you the ability to have that visual and really make sure you're using like the correct upper bound or lower bound in each problem. So 51,200 is the average. 55,000 would be to the right of that, and 65,000 would be even further to the right of that. So we're calculating right now this area between 55,000 and 65,000 miles. What percent of car tires of this brand last between, this interval of values. So when you go to your calculator, we're going to click second VARs, choice 2. In this case, the lower bound should be our 55,000. That's the value to the left of this interval. 65,000 is the one to the right. That should be our upper. The average was 51,200, and the standard deviation was 8,200. And rounding to the nearest thousandth, we should get 0.275. That would represent this sum of percents. Take a moment to try part B if you haven't already. So 48,000 would be to the left, right, of the mean. And we're looking less than. So as far as like visually what that would look like, we do not currently have an actual defined lower bound, so I'm going to use negative 9,999. So that would be my lower, 48,000 would be my upper, same average, same standard deviation. So second VARs, choice 2. Oh, excuse my calculator, needing to show an ad. Okay, how do I click out of this? Sorry about that. Okay, so lower bound, that's the one we made up. Negative 9,999. Upper bound is the 48,000. Same average, 51,200, and same standard deviation. You are hitting enter twice because you're hitting paste enter and then enter on your home screen. I'm hitting enter once because this works a little bit different. 0.348. Again, that represents that area under the curve. Okay, and then for part C and D, we're really doing something similar to what we've done already, but the language changed just a little bit. So if I want to know what is the probability that a randomly selected tire lasts at least 41,000 miles, I want you to think about that word at least. Does that mean we hope it lasts more than 41,000 miles or less than 41,000 miles? So at least, let's also place 41,000 on the curve. At least would mean that is the least amount we hope. We hope for more, right? We don't hope for less. So it's really another way of saying more than. So we're looking for this interval, and when we do this piece, we are missing an upper bound. And if you think about this, we've been using what, the 9,000 number, the 9999. I want you to pause for a moment and think about why that would not be appropriate for this question. And if you actually did this, you probably got an error, probably told you it was like out of bounds, or the boundary was, in the wrong context, because 9,999 is a big number, but it's not a bigger number than 41,000. So this doesn't make sense. So I'm going to add like 2 more nines and make it 999,999, because when you're picking an upper bound or a lower bound, those numbers have to be bigger or smaller than the values in your distribution. So the bigger your distribution values, the bigger you need to make those like boundary numbers. So now let's go to the calculator. Second vars, choice 2. My lower bound is my 41,000. My upper bound, again, you could type in 1,000,000, you could type in any number, just make sure it's bigger, much bigger than the distribution. And then we have our average and our standard deviation to the nearest thousandth, 0.893. And then this last one, 52,000, but we're being asked what's the probability that a tire lasts at most 52,000. So again, I just don't have room, but that would be a little bit bigger than the average. And at most would mean that is the most amount of time we want the tire to last. So that or less. So at most is the same really as saying like less than or equal to. And if you want to go back to at least, that was really like saying greater than or equal to. Okay. So for this question, we're missing a lower bound similar to part B. And it is okay to use negative 9,999, just like it was in part B, because that is much smaller than the numbers in the distribution. It just wasn't appropriate to use 9,999 as an upper bound because it wasn't big enough. So for this last calculation, second vars, choice 2, the lower bound, negative 9,999, comma, the upper bound was the 52,000, my average, and my standard deviation. 0.539. Okay. So I hope that you were able to follow along and learn this new function in the calculator, normal CDF. And I hope that you now take some time to practice on your own without me guiding you through the question. So there are some practice questions. You'll see in your notes, you have a few questions here. If you want to pause the video for a moment and try them, I am going to show the answers on the screen here in just a minute. And then what I would like you to do tonight is to try homework 3. Work on that over the weekend. We'll go over homework 3 on Monday. We'll go over any homework questions from 2 that you starred after checking it also on Monday. And we'll continue on with our unit on Monday. So I hope this video was helpful. And again, as promised, here are the answers to the practice questions. I will see you on Monday.